In this session, we're going to discuss polynomial operations as they relate to multiplication and division. Okay. Polynomial operations, multiplication and division, and right now we're going to focus on multiplication. Alright, so let's start with a monomial times another monomial. Alright, we have negative 5 x to the third y times, let's say, a negative 3 x squared y to the fourth z. Alright, so monomial times a monomial. Monomial meaning one term, that's one term, and that's one term. Okay, so we have a monomial times a monomial. Notice it's multiplication because you have something next to parentheses. You have some term right next to the parentheses. There is not a plus or minus sign between this term and this parentheses for this term. If there was a plus or minus sign here, then that would change it to addition or subtraction. But right now, this term is right next to the parentheses, which tells you multiplication. Similar to if you saw something that looked like, let's say, that. You have a number right next to the parentheses. Alright, so we understand that to be multiplication. So this would be considered the same scenario. Alright, so first we want to multiply the coefficients. So you have a negative 5 times a negative 3. Negative 5 times negative 3. Negative and negative gives you a positive. 5 times 3 is 15. Alright, then the easiest thing to do is look at all of the variables that are present with the terms that you're multiplying. So between these two terms that I'm multiplying, I have a x, a y, and a z. So you can just list all the variables that are present between those terms, x, y, and z. Alright, now with the x's, because we're multiplying, which means we're multiplying the coefficients, negative 5 and negative 3, because we're multiplying the coefficients, then that means we're going to now add the exponents. Add the exponents. So right here you see x to the third, and here x squared. So this 3 plus that 2 now means x to the fifth. Right here I have a y, and this y is like saying y to the first, and here is a y to the fourth. So that 1 and this 4 adds up to be y to the fifth. Now there aren't any z's here. There's a z here, and that one z is represented by us writing the letter z. So z to the first, z to the first. So this would be considered my answer. Let's look at another one. Let's say we have negative 2x to the third. Clean that up a little bit. Alright, 2x to the third times 7x z to the fourth. Okay? Alright, so again, you want to start off by multiplying the coefficients. So this negative 2 times the 7, negative 2 times the 7 gives you a negative 14. Now you write your variables. You have an x, you have an x and a z. So all the variables present are x and z. And then you count how many x's by adding the exponent. So that's x to the third, and this is like saying x to the 1, x to the first. So that 3 plus that 1 is x to the 4, and that z is to the 4th, z to the 4th. Alright, so there's your answer. So now let's try, let's say, a monomial times a binomial. So let's try a monomial times a binomial. Okay. Alright, break it up right quick. Monomial times a binomial. So now we have a negative 3x squared times, let's say, 5x minus 4. Okay, so our monomial, one term, times our binomial, two terms. Binomial, two terms. So again, we're going to multiply the coefficients. So it's like distribution. We're going to take the negative 3 and multiply it by the positive 5, and that's going to give me a negative 15. Then we're looking at the two terms we're talking about right now. We're talking about this monomial and this term right here in the binomial right now. And the only variable we see is x. I have two x's right here, one x right here, so 2 and 1 is 3. Okay, so that takes care of the monomial times the first term. So now I take the monomial, multiply it by the next term. I say the negative 3 times a minus 4, or a negative 4. Alright, so negative 3 times negative 4 is positive 12. The variable is x, and I only have these two right here because this 4 doesn't have an x on it. So I just have this x squared, so I keep x squared. Alright, so my answer then becomes negative 15x to the third plus 12x squared. Alright, let's try a monomial times a trinomial. So 2x to the third times a negative 5x squared plus x minus 2. Okay, so once again it's going to be like distribution. So you're going to say this term times this term times that, and this term times that. So when we do the first two, that gives us a 2 times a negative 5, which is a negative 10. We have x to the third, x to the second, so that's going to be x to the fifth. Now that takes care of that one. So now we're going to say 2x to the third times this positive x, the next term. Well, the only coefficient is the 2 times this 1, so that's giving me a positive 2. The variable between these two that I'm looking at is x, and I have 3 here and 1 here, so 3 and 1 makes this to the fourth, and then I go 2 times a negative 2, which is a negative 4, and I keep my x to the third. X to the third, there is no x here, so I just keep that x to the third. There's my answer. Okay, now let's look at a binomial times another binomial. Okay, so let's say we have something like 2x plus 1 times 3x minus 7. Alright, binomial times another binomial. Okay, so here's what we want to do. It's called horizontal multiplication. Alright, and what you're going to do is you're going to take the terms of the first polynomial, whatever it is, in this case it's a binomial, but you want to take each individual term in the first binomial and multiply it by the entire second polynomial. Okay, So watch. We want to take this 2x and multiply it by the second polynomial, and then we want to take this plus 1 and multiply it by the second polynomial. Alright, so we're going to say 2x times 3x is 6x squared, because x to the 1 and x to the 1 is x to the 2. Then you're going to say 2x times a negative 7 is a negative 14x. Alright. Now the 1 and the 3, it's a positive 3x. The 1 and the negative 7 is a negative 7. Okay, so we took the first term in the initial polynomial and multiplied it by whatever polynomial was next using distribution. Then once we multiplied it by everything in the following polynomial, we took the second term in the initial polynomial and multiplied it by everything in the second polynomial. Okay, so once we multiplied everything out, now we want to always, after we finish multiplying everything out, we want to always look to see if there's anything that we can combine based on them being like terms. And in this case, right here, this negative 14x and this positive 3x are like terms. So when you combine those, you simply bring down your 6x squared. Now when you combine these two right here, the negative 14 and the plus 3, it leaves you with a negative, what is that, 11x, and then you bring down your minus 7. Okay, so your answer is 6x squared minus 11x minus 7. Let's look at another one. Let's say we have 3x plus 2x minus 1. Okay. Alright. So I want to take the 3x, multiply it by x minus 1. Then I want to take plus 2, multiply it by x minus 1. Okay. 3x plus 2. Alright. So the 3x times this x, 3x times x, 3x squared, 3x times a negative 1, negative 3x. Now you have 2 times x is a positive 2x, and 2 times negative 1 is a negative 2, like terms. So you end up with 3x squared, negative 3x plus 2x is a minus 1x, so minus 1x, and you bring down your negative 2. There's your answer. Alright. Now, let's look at, let's say, a binomial times a trinomial. Let's try this. Alright, so 2x minus 1 times x squared minus 5x plus 3. Okay, so now once again we want to take whatever's in the first polynomial and break it up into pieces. So 2x, and you, whatever, each term out of the first, you're going to multiply it by the entire second. So x squared minus 5x plus 3. Now, this is minus 1. Minus 1. See the minus sign in front, so you're going to write minus 1. Alright, minus 1. That's going to be times whatever the following polynomial is. Okay. So 2x times x squared is going to be 2x to the third, because x1 and x2 is x3. 2x times a negative 5x, negative 10 x squared. 2x times 3 plus 6x. Now, you've multiplied this 2x, the first term, in the first polynomial by the entire second polynomial, so now you move to the next term and multiply it by the entire second polynomial. So now this negative 1 times x squared is going to give you a negative 1 x squared, negative 1 x squared. Remember, we don't write the 1, it's understood to be there. This negative 1 times a negative 5x. Negative times a negative is now positive 5x. And a negative 1 times a 3 minus 3. Okay. So we've multiplied everything out. So once again, once we multiply everything out, we want to try to combine like terms. So I see I have an x squared and an x squared here. I have an x and an x here. So I'm going to combine. Bring this down. 2x to the third. Negative 10x squared minus 1x squared. Negative 10 minus 1 is a negative 11 x squared. I have a 6x plus a 5x, which is a positive 11x. Okay, and nothing to combine with my constant, so I bring it down. Minus 3. Alright, that would be your answer. That would be your answer right there. There. Okay. We can look at another one real quick. Let's say 2x squared minus x plus 1 times 3x plus 4. So now we have a trinomial times a binomial. Alright. So again, we take the first one, break it up into its individual terms, and multiply each term by whatever polynomial is next. So we say 2x squared times 3x plus 4. Then you say minus x times 3x plus 4. Then you say plus 1 times 3x plus 4. So that term, and that term. Okay. So 2x squared and 3x is 6x to the third. 2x squared plus 4 is a positive 8x squared. Negative x times 3x is a negative 3x squared. Negative x times 4 minus 4x. 1 times 3x is just going to be 3x. 1 times 4 is just going to be 4. Combine like terms. These terms are alike. These terms are alike. Bring my 6x to the third down. 8x squared minus 3x squared. Positive x squared. Negative 4x plus 3x is a minus 1x. And I bring down plus 4. So that would be my answer. Okay. So this is basically how to multiply your polynomials using horizontal multiplication, or what I would typically just refer to as universal method. Doesn't matter what kind of polynomial situation you're given, you use this method that you see here, and it will work in any case. Alright. Now, still dealing with multiplication. Alright. we're going to talk about some special cases. Alright. First, if you have a binomial times a binomial, 3x plus 1 times 2x minus 5. Alright, we've already shown that using the previous method, horizontal, or what we call the universal method, or what I call universal method anyway, we would get this by saying 3x times the 2x minus 5, and then plus 1 times the 2x minus 5, getting 6x squared minus 15x plus 2x minus 5, 6x squared minus 13x minus 5 being the answer. Okay, that's based on what we just learned. Now, because we're multiplying two binomials, there's another method we can use, and it's called the FOIL pattern. FOIL, F-O-I-L, FOIL pattern, and it stands for first, outside, inside, last. First, outer, inner, last. Okay, and with the FOIL pattern, what you're going to do, first of all, you have to understand that FOIL only works when you have a binomial times another binomial. That is the only time FOIL works. The only time FOIL works is when you're multiplying two binomials. Now, what you're going to do is you're going to multiply something from the first binomial times something from the other binomial, the second. So, if we're talking the first, the f, right? First, this 3x is the first term in this binomial, and the 2x is the first term in this binomial. So, for the f, we'd multiply those two things. Alright? For the outside, the O, outside, outer, we'd multiply this 3x right here times this minus 5 right here. Alright, so each term gets two designations. It'll get an F and an L designation, and it'll get an O and an I designation. Okay, so the 3x is considered an F, but it's also considered an O. Alright, so for first times first, you'll get 3x times 2x. For outside, you'll get 3x times a negative 5. Okay, inside, since 3x and the minus 5 are the outside, then the plus 1 and the 2x are the insides. Okay, and then now my last goes to saying this plus 1 is the last in this binomial, and the minus 5 is the last in this binomial. Alright, so let's take a look. For our first, we say 3x times 2x. 3x times 2x. That gives us our first. Okay. For our outside, we have 3x times negative 5. 3x times a negative 5. Our inside, 1 times 2x, so positive 1 times 2x, and then our last times last, which is this 1 times this negative 5. Alright, so when we multiply 3x times 2x, that gives me 6x squared. Alright, when we multiply 3x times a negative 5, it's a minus 15x. 1 times 2x is a positive 2x. and then 1 times negative 5 is just a negative 5. Now if you notice, our outside and our inside gives us like terms, so they can be combined to give a negative 13x, and we simply bring down our minus 5 and our 6x squared. So the answer being 6x squared minus 13x minus 5, which you see is nothing but what you got here. So FOIL is nice and easy to do if you have two binomials, but really if you understand the horizontal multiplication method, which we just went over with the last set of problems, if you understand that, then you can deal with these whether or not you are able to remember all of these little special cases that we're about to cover in the next few minutes. Okay, so just for additional practice, let's do another FOIL. So 2x minus 1 times 8x minus 7. Alright, so first and first, it's going to be the 2x is the first here, 8x is the first over here. So in this parenthesis, 2x is first. In this parenthesis, 8x is first. So 2x times 8x gives me 16x squared. Now my outside would be the farthest to the left times the farthest to the right. Farthest to the left times the farthest to the right. So 2x times a negative 7 is a negative 14x. Inside is going to be the opposite of outside. So if 2x times negative 7 was the outside, then the inside will be this negative 1 and this 8x. So the two that are right side by side each other is the inside. The two that are side by side each other is going to be the inside. So that's going to give me a negative 8x. And then my last times last, this negative 1 is the last in this set of parentheses. This negative 7 is the last term in this set of parentheses. So negative 1 times negative 7 is a positive, because negative times a negative is a positive. So positive 7. Once again, my outside and inside terms are alike. So bring down 16x squared. Negative 14 minus 8 is what, a negative 22x. And bring down plus 7. There's your answer. Alright. Now, aside from these, you'll have problems like this. Alright, so again, two binomials. So we could do FOIL. So first and first, 4x squared. Outside, this 2x is the farthest to the left, times this 1 is farthest to the right, gives me a positive 2x. Inside, this negative 1 and this 2x, right? They're side by side to each other, so that's the inside. So that's a negative 2x. And then last times last. This negative 1 is the last in this parenthesis, this positive 1 is the last in this parenthesis. Negative 1 times positive 1 is a minus 1. So now, outside and inside are like terms, but if you notice, 2x minus 2x, they cancel each other. 2x minus 2x, they end up canceling, and you just end up with 4x squared minus the 1. Let's try another one. Let's say 9x plus 2 times 9x minus 2. First and first, 81x squared. Outside, minus 18x. Inside, plus 18x. Last and last, minus 4. Outside and inside, these are like terms. these right here are like terms. You notice a negative 18 and a positive 18, they cancel. So you just have 81 x squared minus 4. Okay. Now, basically what they're wanting you to understand here is when you're multiplying two binomials, and pretty much they're the exact same binomial except for the sign in the middle. Notice the sign is a minus sign and this sign is a plus sign. This sign was a plus sign, this sign is a minus sign. The two binomials look identical except for the sign in the middle is the opposite. Identical binomials with opposite signs in the middle. Alright, so all they're wanting you to understand is when you have a situation like this, then which they call a plus b times a minus b, and all they're saying is a is whatever your first term is, so say 2x, and b is whatever your second term is, so let's say this one right here. So anytime you have identical binomials being multiplied but the sign in the middle is opposite, then your answer is just going to be whatever the first thing is squared minus whatever the last thing is squared. So if you look, the first thing was 2 in this problem. 2x, excuse me. The first term was 2x. So if I square 2x, I get 4x squared. Then I wrote your minus sign. The last term I have is a 1 in this binomial. And if I square a 1, 1 squared is just 1. And there it is. A squared minus b squared. There it is. Look at this one. The first term is a 9x. So if you square 9x, 9 squared, 81, x squared, 80 is x squared. So 81x squared. Write my minus sign. Then my second term is a 2. If you square 2, you get a 4. There's your answer. Alright? So this is what they're talking about. Special cases. This is one. The two binomials, first of all, they're binomials and they're the exact same but have an opposite sign in the middle. Okay? Next case. Says if you're squaring the sum of a binomial, okay, it's going to equal whatever the first term is squared plus 2 times whatever the first term is times whatever the second term is plus the second term squared. So let's look. Let's say we have 2x plus 3 squared. Well, my first term, my first term is 2x. My b is a 3. So based on this, all I'm going to do is square my a. So if 2x is my a, then I'm going to square it for my answer. So if I square 2x, I get 4x squared. Plus, now it says, I'm going to say 2 times whatever a is. We're saying a is 2x. And we're saying b is the 3. And then we're saying it's going to be plus b squared. So plus 3 squared, which is just 9. Now, 2 times 2 is 4x. 4x times is 3. 4 and 3, 12x. So the answer would be 4x squared plus 12x plus 9. Alright? Special case. Now, that's all fine and dandy for you to understand this. If you understand this, fine. But again, if you understand what we were doing with the problems previous, when we were talking about the horizontal method, then if I gave you 2x plus 3 squared, and you understand that square means to multiply something by itself or to write it down 2 times, then you would take this and rewrite it like this. Right? 2x plus 3 squared means 2x plus 3 2 times. Write it out 2 times and multiplying it by itself. That's what it mean. That's what we mean by square. That's why we mean square. Okay, and if you did that, you take your 2x times 2x plus 3. Then you take your plus 3 times 2x plus 3. And guess what? That gives you 4x. That gives you plus 6x. That gives you plus 6x. That gives you plus 9. 6 and 6 is 12x. Bring down your plus 9. Bring down your 4x. And if you notice, same. So as long as you understand this right here, you're good. Now, these special cases are just ways of kind of doing shortcuts, so to speak. Alright, so if you catch on to this, fine. But if not, you can always revert back to our horizontal method. Just understand that the square, something squared, just means to write it out twice. And once you write it out twice, then you should be able to do it no problem. Okay, so just like we have the sum of the square of a binomial, you also have one for the difference of the square of a binomial, and that one's going to be whatever a first term is squared minus now 2 times the first term times the last term plus whatever the last term is squared. Alright, so let's say 3x minus 2 squared. Alright, so our a is 3x and our b is 2. Alright, these formulas account for the sign, so don't worry about this 2 being a negative. Just write it as a 2 because the formula accounts for the signs. Alright, so you would simply say the answer then is going to be whatever the first term is squared. The first term, the a, we said is 3x, so that's squared minus 2 times whatever a is, and we said a is 3x, times whatever b is, and we said b is 2. Okay, plus b, which is 2 squared. 3x squared equals 9x squared. 2 times 3 is 6. 6 times 2 is 12, so minus 12x. Alright, and plus 4. Okay, so our answer is 9x squared minus 12x plus 4. Alright, but again, you don't have to get caught up in all of that. If you understand what it means to be a square, then you would just take this problem and write it twice. Right? You started off with 3x minus 2 squared. That squared just means write it 2 times. So now, use your horizontal, or you could use FOIL if you wanted to, since both of these are binomials. And you have 9x squared minus 6x minus 6x plus 4. These are like terms, so when you finish, you get 9x squared minus 12x plus 4. And once again, that answer is the same you got when you plugged in that formula. Okay? Answer is the same. So if you hold on to the horizontal method, what I call the universal method, if you have a true understanding of that, then these formulas, these special case formulas, they're just extra. Okay? If you get them, fine. If you don't, fine. But these are the special cases that they're talking about. Okay? In addition to doing the FOIL method. Alright? So those are the special cases they're talking about in addition to FOIL method. But what we just proved is that as long as you hold on to knowing our basic horizontal method, universal method, then you don't have to memorize these special cases. You'll get there. Alright, you'll get the same answer. Okay, lastly, we're going to talk about division. Alright, so let's start with a problem that looks like this. 9x to the 5th minus 12x squared plus 3x all over 3x. Okay, with division, what you want to do is take, as long as the denominator is a monomial, that's the key. Alright, we're talking about division with a denominator that is a monomial. Okay, let's say monomial denominator. That's what we're focusing on. Then all you have to do is take each term in the numerator and put it over the denominator. So you would rewrite it as 9x to the 5th over 3x minus 12x squared over 3x plus 3x over 3x. So you took each term in the top in the numerator and wrote it over the denominator. Alright, so 9 over 3 is like saying 3 over 1, right? 9 over 3 is like saying 3 over 1. X to the 5th over x. Now, when we were multiplying, we were adding exponents. So division is the opposite of multiplication, so instead of adding exponents, we're going to subtract exponents. But here's the thing, when you subtract the exponents, you're going to write the answer where the biggest exponent was. So I got x to the 5th and an x to the 1. So I'm going to say 5 minus 1, which equals 4. And since the biggest exponent is in the numerator in the top, I'm going to write my x to the 4th in the top. Write my minus. 12 over 3 is like saying 4 over 1. X squared, x to the 1st. 2 minus 1 is x to the 1. And since the bigger exponent is in the top, that's where I write my x to the 1. Remember, x to the 1 is the same as just saying x. Plus 3x over 3x. That just cancels. It's like saying 1 over 1, because 3 goes into 3 one time, 3 goes into 3 one time again. The x's cancel, okay, because that's like saying 1 minus 1, which would be 0. So there you have it. Now we know that having 1 in the denominator of a fraction can be negligible, so you can just simplify this to look like this right here. Okay, so that's that one. Alright, let's try another one. Let's go with 8 x to the 6th minus 16 x to the 4 plus 2 x to the 3rd all over 4x squared. So again, we have a monomial denominator, so we take each in the top and write it over our denominator. Okay, and just begin simplifying. 8 over 4 is like saying 2 over 1. X to the 6th, x to the 2nd. 6 minus 2 is 4, and because the 6 is in the numerator, we write our x to the 4 in the numerator. Write our minus sign. 16 over 4 is like saying 4 over 1. X to the 4, x to the 2. 4 minus 2 is 2, and because the 4 is bigger than the 2, we write our answer in the top. So x to the 4 minus x to the 2 gives me x squared. Write our plus sign. 2 over 4. Now, this is 2 over 4. This is not 4 over 2. This is 2 over 4. So that does not give me 2. That gives me 1/2. 2 goes into self 1 time. 2 goes into 4 2 times. So 1/2. X to the 3rd. X to the 2nd. 3 minus 2 is 1. And because the bigger is in the top, the bigger exponent is in the top, I write my x to the 1 in the top. So remember, x is like saying x to the 1. So now when I simplify this, because this is over 1, I can just say 2x to the 4 minus, this one's over 1, so I can just say 4x squared plus, now this one's not over 1, so I have to write it out, 1x, which is just x, and I have a 2 in the denominator. So this would be how I'd write the answer. Alright. Next, 9x to the 5th plus 6x to the 3rd plus 12x all over 3x to the 3rd, 9x to the 5th over 3x to the 3rd plus 6x to the 3rd over 3x to the 3rd plus 12x over 3x to the 3rd. 9 over 3, it's like saying 3 over 1. X to the 5 over x to the 3. 5 minus 3 is 2. The 5 is in the top, the bigger exponent is in the top, so I'll write my x to the 2 in the top, plus 6 over 3. Again, it's like saying 2 over 1. X to the 3rd, x to the 3rd. Okay, so my x's cancel, so there aren't any x's, because 3 minus 3 gives me a 0, so there won't be any x's. Write my plus sign. 12 over 3 is 4, so like saying 4 over 1. I have x to the 1 and x to the 3. 3 minus 1 is 2. 3 minus 1 is 2. But because my bigger exponent is in the bottom now, notice this is in the denominator now, I write my answer in the denominator. So I write my x to the 2nd, x squared in the denominator. So when I rewrite 3x squared, I can leave off the over 1 part, plus 2, I can leave off the over 1 part, plus 4 over x squared. There's my answer. Alright, last one. Let's say 10 x to the 3rd y squared minus 12 x y to the 3rd plus 2 y to the 5th all over 4x squared y. Alright, so take my 10x to the 3rd y squared, write it over 4x squared y minus my 12x y to the 3rd, write it over 4x squared y plus my 2y to the 5th, write it over 4x squared y. Now 10 over 4, it reduces. 2 goes into 10 5 times, 2 goes into 10 2 goes into 10 5 times, 2 goes into 4 2 times, so that breaks down to 5 over 2. I have an x to the 3 over x to the 2. 3 minus 2 is x to the 1. It's a bigger exponent for the x's in the top, so I write my x to the 1 up top. I have a y squared over y, y2 minus y1. Okay, 2 minus 1 is 1. Bigger exponent is up top, so I write my y to the 1 up top, minus. Alright, 12 over 4, which is like saying 3 over 1. X to the 1 over x to the 2. 2 minus 1 is 1. My bigger exponent for the x is in the bottom, so I write my x to the 1 in the bottom. Y to the 3rd over y to the 1st, y1. 3 minus 1 is 2. Bigger exponent is in the top, so I write my y2, my y squared in the top. Now I have a 2 over 4, which is 1/2. I don't have any x's in the top. I have x's in the bottom, so I keep them in the bottom. I have a y to the 5th in the top, a y in the bottom. 5 minus 1 is 4. Because the bigger y is in the top, I write my answer in the top. So when I simplify my answer, I end up with 5xy over 2 minus 3y squared over x plus y to the 4th over 2x squared. And that would be my final answer. Alright, so hopefully Again, this gives us a better understanding with division, and we've talked about a lot here. So take your time and go back through the individual sheets or slides, whatever you want to call them, and make sure you have a good understanding of what was covered. And at this time, we'll conclude this session.